to be covering reversible reactions and chemical equilibrium, which is very important because it almost always comes in your chemistry paper 4 exam, and it usually comes with your rate of reaction questions, which we've already covered. So let's just dive right into it. So reversible reactions are fairly simple, and by their definition are reactions that can be reversed. So from the reactants, you go to the products, and then from the products, you go to the reactants. The symbol that is used to denote a reversible reaction, it's half an arrow forward and half an arrow backward. When you see this, you will immediately know that the reaction is reversible. Now, this is the same thing as I have done here. 1 arrow forward, 1 arrow backward. However, since you want one symbol, it's represented as 1/2 arrow in the forward direction and 1/2 arrow in the backward direction. An example of a reversible reaction would be the formation of ammonia. Now, the forward reaction is from the reactants to product, which is the nitrogen plus hydrogen giving ammonia. And the backward reaction is from the products to the reactants, which is from ammonia to nitrogen and hydrogen. Now, what this means is that nitrogen and hydrogen is forming ammonia, and ammonia is also decomposing into nitrogen and hydrogen. This is why the reaction is reversible. It occurs in both directions. You can go from the reactants to the products, and you can go from the products to reactants. Another example would be the formation of the blue crystals by copper sulfate. These are blue crystals. Whoops. Okay. Now here, when you add water, you get crystals. If you dehydrate it, if you apply heat, if you give it heat, dehydrate, the water evaporates, then you will no longer have crystals. You will have copper sulfate and you will have evaporated water. Therefore, the reaction is reversible. Now, chemical equilibrium occurs for reversible reactions. Now, the definition of chemical equilibrium is very, very important. It is a very common question in your paper 4 exam. It comes for 2 marks. Now, what is equilibrium? The essential concept of chemical equilibrium is when the rate of the forward reaction is equal to the rate of the backward reaction. That is the main thing about equilibrium, when the rate of the forward reaction from reactants to products is equal to the rate of the backward reaction from the products to reactants. This will give you your first mark. The second mark will be gained by saying that the concentration of reactants and products remain constant. It is very important for you to say this, because if you do not mention this, you will not get 2 marks, and the definition for chemical equilibrium is always 2 marks. Now, again, very simple concept. Rate means the speed of a reaction, speed. So what they're basically saying is that the speed of the forward reaction, the speed of the reactants becoming products, is equal to the speed of the products becoming reactants. The speed of ammonia forming is equal to the speed of ammonia decomposing and forming nitrogen and hydrogen. Now, equilibrium can be altered. Its position can be altered, so it favors whatever it is that you want. Now, there are 2 factors affecting equilibrium: temperature and pressure. Now, for reaction rate, we had seen that if you increase the temperature, the reaction rate increases. If you decrease the temperature, the reaction rate decreases. Fairly simple, directly proportional. However, for equilibrium, it is not as straightforward. You need to establish a few things to determine the equilibrium position in accordance to temperature. Now, for temperature, you need to know To know how temperature is affecting the equilibrium position, you need to know if the reaction is exothermic or endothermic, if the forward reaction is exothermic or endothermic. Let's look at an example. Let's look at the reaction rate that we're using over here. There we go. Now, the forward reaction from the reactants to products, nitrogen hydrogen forming ammonia is an exothermic reaction. Exothermic reaction. The forward reaction is exothermic. Now, if you want the equilibrium position to shift to the right side, if you want it to go in the forward direction, then you will lower the temperature. Why? Because lower temperature favors exothermic reaction. Really, it's the simple fact that you need to remember. That lower temperature favors exothermic reaction. So if you lower the temperature of the system of this reaction, then the equilibrium would shift to the right side. Lower temp, equilibrium, right side. Now, if you wanted for the equilibrium, for whatever reason, or just for the sake of understanding, let's say that we wanted the equilibrium to shift to the left side. Now, if the forward reaction is exothermic, then the backward reaction would be endothermic. That's just how it is. If the forward reaction is exothermic, then the backward reaction is endothermic. And since if you want the equilibrium to move backwards, you are going to increase the temperature, because increase in temperature favors endothermic reactions. Right. Again, very important point. The only two important points that you need to know for temperature and equilibrium. Decrease in temperature favors exothermic reaction, and increase in temperature favors endothermic reaction. So if we increase the temperature in this reaction, our equilibrium would move to the left. Now let's look at pressure. For pressure, we would have to look at the molar ratio. Again, let's use the same reaction. There we go. Now, you need to count the amount of moles on each side. You need to know the amount of moles on the reactant side. You need to know the amount of moles on the product side. So let's count. On the reaction side, we have 3 plus 1, because when you have nothing there, it's equal to 1. 3 plus 1 is equal to 4. And over here, we have only 2. So where will our equilibrium shift to? Equilibrium will shift to the right. Why? Because increase in pressure favors side with smaller number of moles. Simple as that. You count, or if you don't even want to bring the word moles into it, just count the coefficient of each compound or element or whatever it is that you have in your reaction. Count the coefficient, the total on the reactant side and the total on the product side, and we'll see which one is smaller. If you're increasing the temperature, then equilibrium will shift to the smaller side. Now, if you wanted equilibrium to shift to the left, what you would do is you would decrease the pressure, sorry. You would decrease the pressure if you wanted equilibrium to shift to the left. But I don't want you guys to think about decreasing the pressure, I'm so sorry. The only point that you need to remember is that increase in pressure favors the side with smaller number of moles. If you understand this, if you have this embedded in your head, you will automatically be able to decipher what you need to do for if you're you will automatically be able to decipher what you need to do for the reaction to shift to the side with the greater number of moles. So all that really matters is that when you increase temperature, equilibrium is shifted to the side with the smaller number of moles. And that's pretty much the entire concept. And this concept is super, super important for your paper 4 especially. Now I want to look into a question so you know how to gain your marks. Oh, that reminds me. One thing that you do need to remember is that a catalyst does not alter or affect equilibrium position. It only ever increases the speed or increases the rate of reaction. Does not affect equilibrium position. It does not partake in the reaction. It does not change it does not alter the position of equilibrium. It only increases the speed of the reaction. Now let's look into a past paper question. This is not the complete question because the rest of it was electrolysis, and although we've covered that, I know some of you have not watched that video, so we're only going to do questions relevant to our lesson today. Also, the next video that I'm going to be doing will be rigorous past paper practice on the chemical equilibrium and reaction rate chapters only, so you guys will be sure of having a thorough understanding of those two topics. So we're going to do a bunch of paper 4, a bunch of paper 2, and maybe paper 6 questions as well. Okay, so the next video will be longer, much longer actually, and it's very beneficial because we're going to be answering a lot of past paper questions related to these two topics. So let's read the question. Hydrogen can be manufactured from methane by steam reforming. The reaction is carried out using a nickel catalyst at temperatures between 700 degrees Celsius and 1100 degrees Celsius and using a pressure of 1 atmosphere. The forward reaction is endothermic. Now, what is meant by the term catalyst? So a catalyst is a substance that increases the rate of reaction. If you say this, you will get 1 mark. If you only say this, they will not give you the total 2 marks that you want. You also have to say that it remains chemically unchanged. Or you could say that it does not take part in the chemical reaction. Or the ideal response is that the substance that increases the rate of reaction, it is a substance that increases the rate of reaction and it remains chemically unchanged. This will give you your 2 marks. Now, so just 2 reasons why temperature lower than 700 degrees is not used. You need 2 reasons. So first of all, let's look into the reason that we only recently learned. And it's that the forward reaction is endothermic. And what you are doing is that you are lowering the temperature. Lower temperature favors the exothermic reaction, which means that your equilibrium will shift to the left. And when that happens, your yield is decreasing. The product amount is decreasing because equilibrium is shifting to the left side. So why would you not lower the temperature? Because equilibrium will shift to the left and because lowering temperature is favoring the exothermic reaction, which is the backward reaction or the left reaction, and therefore our product yield is decreasing. So it decreases yield. The second reason is that a decrease in temperature decreases rate of reaction. So slower reaction. 2 reasons, 2 marks. So just one advantage of using pressure greater than 1 atmosphere. This is 1 mark, so you can immediately just write that faster reaction, because increase in pressure increases rate of reaction. Both temperature and pressure are directly proportional to the rate of reaction. So just one disadvantage of using pressure greater than 1 atmosphere. Let's look at the amount of moles that we have on each side. So 1, 1, that gives us 2 total on the reaction side. 3, 1, that gives us 4 total on the product side. Now, if we increase the pressure, by the way, this might confuse a few people when they say greater than 1 atmosphere. It does not matter. The number that they have mentioned does not matter. What they really care about and what they mean over here entirely is that you are increasing pressure. So what is the disadvantage of increasing pressure? Again, what we saw over here is that increase in pressure favors site with the smaller number of moles. So which side is being favored? The reactant side. That is the smaller number of moles, which means that our equilibrium is once again shifting to the left, and therefore our product amount is decreasing. So it decreases yield. 1 mark gained. So I hope you guys were able to understand the concept. I hope you have a thorough understanding of it. And if not, then don't worry, because we're going to do a lot of past paper questions in the next video. So hopefully you will understand there. If you have any questions, let me know in the comments. If you know anyone who needs the help, please share the video. And yeah, I'll see you guys next time.